Hello everyone, and thanks for coming here for my PhD dissertation defense. I'm so glad to see so many familiar faces in one place. It makes me a little bit less nervous. You can be prepared as much as you want, but still it's going to be a little bit stressful. It's not worse than the job market, but you know. I used AI to make me a good shield to defend myself. All of the prompt engineering techniques I had, so hopefully it's going to save me. As you may have seen in the email, the dissertation is about the interaction of humans and artificial intelligence, especially in the age of large language models. And it includes 4 chapters. You can see like the first one is about explainability of AI. The second is also about explainability, but a little bit more practical. The third chapter is about a trade-off between creativity of AI models and their safety. And the last one is a programming language, believe it or not. So let me just give you a bird's eye view of these chapters. Someone is sending me. OK.
I'll keep track.
OK, cool.
It comes up on chat.
I see. OK. So the first chapter I presented here actually a few years ago. First summer paper joint work with Nikhil, who's joining us on Zoom, Tim, and Kannan, who's also on Zoom. And really, I'm not going to get into much detail about this chapter because, I mean, I presented it before, but I will still say something about the model and what we did. So it was a game theory model, analyzes the economic implications of regulating firms when it comes to AI transparency. And you can see that there's a duopoly, like 2 firms trying to provide AI products, and they may or may not provide explanations for those AI models. And then there's like a policymaker that is looking at the whole thing and tries to optimize the welfare or some other objectives that we consider in the model, like the consumer surplus or just the XAI fairness. And we find out some like counterintuitive results. Like there are cases where unregulated markets, where like you just let the firms choose whatever they want to do, actually outperform regulated markets, where like let's say GDPR enforces every firm to provide full explanations. And there are cases that that's actually worse than letting firms choose what they want. There's nothing stopping us from like offering other policies. Like no one says it has to be fully regulated or fully unregulated. We offer a number of policies that are in the middle, and they're a little bit more flexible. We show that they can actually outperform the current policies. I guess the one message I want to leave you with this paper is that AI regulation is more nuanced than some people realize. And just because you think that enforcing regulations of transparency is going to help customers doesn't actually mean that it's going to happen. So there are cases that full explanations, or at least enforcing full explanations, can actually make the very customers that you're trying to protect worse off. And then there's like this interesting result that we found towards the end of the project where some firms argue that they don't want to provide explanations out of fear of, let's say, privacy of their model being jeopardized, or like other firms sort of reverse engineering their model if they see how it works. Turns out, even if we don't allow that in the model, which we don't, that still happens. There's a correlation between your explanations and the accuracy of the other firm quality. And turns out that's just the firm's differentiation at play. So you might have situations where OpenAI might think if they reveal the reasoning of O1, it might let other firms replicate the model. And it turns out that even without it, R1 from DeepSeek was able to do that. So the R1 is a model where it provides explanations. On the other hand, you have OpenAI that doesn't provide explanations, and then there's a quality gap between them. So the apparent correlations between your level of transparency and the other firm's success in building an AI model is not necessarily due to them reverse engineering your model. It's just the way the market works. At equilibrium, you differentiate on quality and explanation levels. And this paper was published in Market Science last year. So that's the first one. The second one says, OK, we studied XAI from an economic perspective. Now let's go ahead and get our hands dirty and actually make an XAI method. So this paper says there are ways to like interpret large language model outputs. There are people who are trying to simulate customers using language models, and turns out that it's a little bit more challenging and also more tricky than people realize. We need to understand that these models are very sensitive to the prompt that they use, and depending on the prompt, you might get totally different results. So we need robustness checks for research or experiments that try to mimic customer behavior. And that robustness check is one way to do it is the Shapley value method that I introduced in the paper. And it leads to some effects like token noise effect, where the AI actually focuses on parts of the prompt that are not important in your opinion as a researcher. Like you don't put them in your utility function model, and yet they're actually driving the decision making of the model. So there's like a lot of difference between human cognition and language models' understanding of questions. I will show a little bit more example, some more examples of this. And the third chapter is about the trade-off of creativity and safety. You know, you have models that are safe, meaning like you talk to ChatGPT, it's not toxic or biased, it's predictable, it's friendly, that's nice. But it comes at the cost of losing its creativity, meaning that it cannot generate all kinds of outputs for you. And this is a discovery paper. Basically, it shows that this problem exists. And then towards the end, we understand that, OK, even if you try to make the aligned models like ChatGPT a little bit more creative, it doesn't work that way. It's not that easy. You actually have to get at the transformer level, modify the transformer, and try to make the model output more diverse in the sense that you want different outputs from the model. And so for marketers, it's extremely important. It means that one size fits all doesn't fit here either. I guess the whole dissertation is about one size fits all doesn't work. So the first chapter, we saw the one size fits all regulations don't work. Now we see that you can't just use one model for all marketing applications. If your application is requiring a lot of consistency and predictability, you want to use aligned models. Otherwise, you better use base models. And finally, the Pell programming language. Now, I'm a PhD student in marketing. What business do I have creating a programming language? Aside from the fact that it's just like because, and I am passionate about this thing, it comes from a real need. At Center for Intelligent Business, we were thinking about how to democratize AI for small businesses. And so one of the projects that I started was the Beacon project, where you want to simulate a lot of like departments of a company using AI. But then the challenge is how do you coordinate and sort of orchestrate all these like the sections of the company, because it has to be autonomous. And so the current methods are limited when it comes to the number of actions that that department can take, or how many departments you can use with current AI frameworks. So Pell is a solution to that. It provides some really nice qualities that I will show you in the slides, and I will show some sample code. All right, so together these 4 chapters for my dissertation. If it wasn't for Pell, I could have defended a couple months ago, but I thought this is like one last big project to do, and it was. I hope that it was worth it. This one I said I'm not going to talk about that much. Moving on. That was the fastest chapter. So like I can talk about explainability. I have like 22 minutes left, right? So I'm going to like go super fast in this one. But OK, some examples I can't skip really. Like there are research papers or like at least arguments that say, you know, LLMs can be used to simulate consumers, right? But then like there are counterexamples like this that show LLMs don't even understand the concept of price increase. So you might actually simulate a consumer using AI that like reflects the real world data that you have, but then how much of it was just pattern matching, and how much was actually understanding that the price is increasing. Like it thinks 9.11 is bigger than 9.9 because 11 is more than 9. Now for Python, it works. Like 3.11 is newer than 3.9. It's the software. But for like digital or like for digits, it doesn't work like that. But more importantly, there are examples like the one that I'm going to show you that typically marketers are interested in discrete choice experiments to understand the preferences of models. Oftentimes, this is associated with like a utility model that you have, like in a conjoint, you think there's like some parameters that you want to find the coefficients of. And so this prompt that I used here is just an example on Llama 3 8 billion. You start adding new lines after this question. So like you're not changing anything about the question. You just keep adding new lines and the choice probabilities change. Just let that sink in a little bit. And in fact, it turns out if you try to do it for like 200 lines after this thing, just add empty space after the question, there's fluctuation between choice probabilities. So you end up having all choice probabilities that depend on the empty space. Now, as a researcher in marketing, do you actually put a coefficient for something's happening? Do you actually put coefficients in your utility function, that one coefficient about the empty space in the questionnaire? Or is it more like you think that the user is going to care about like price and travel time and other factors? Turns out there are some abnormal behaviors like this that are concerning when we're trying to simulate consumers using AI. The proposed Shapley value method in this paper says, let's just treat all of the like components of the prompt as if they're players and they're playing a game. It's a cooperative game. And they're going to get some payoff. And the payoff is the choice probability of flight A. And not all of them contributed equally, right? So we want to understand how to fairly distribute that choice probability among all these players. Mind you, if your research question is different, you can decrease the resolution. Maybe you're interested in just this whole sentence as one player and then this sentence as another one. So it's all up to you. It has a lot of flexibility. But like if you go ahead and do this, you can like use the Shapley value method, which is a concept from game theory that tells us how to distribute some payoff among players who play the game, depending on their average marginal contribution to the coalitions that could be formed. I would want to talk about how it works, but I'm going to show you animation now because there's the lack of time. Yeah. So you can see some stuff happening. At least I can show off the cool animations. But so like at each step, you form like coalitions where like you say, OK, this part of the prompt, if I give it to the language model, is going to give me some choice probability. Then if I inject another token, it's going to change that choice probability. So you record that marginal contribution. And you repeat it over all the possible ways you could have formed those coalitions. And when you take an average, it's the Shapley value. Skipping over these things in the interest of time. So really, if you were to go ahead and calculate Shapley values, intuitively, you would think that the question like about like flights and with prices and travel time, more you would expect as a marketing researcher or a person trained in economics that price plays a huge role. Like the travel time also must be important, right? These are the things that we think at least humans care about when they choose between options. And the other ones, not that they don't matter at all, but their influence should be much smaller than the actual informative tokens, right? Well, turns out it's not the case. In like a series of models, not just like one model, we can show that there's good news and bad news. The good news is that indeed the model cares more about the second part of the prompt where you are talking about the flights, but it also cares as much about the price of flight B as the word the at the beginning of the sentence. So if you include the word the, or if you include $600 as the price of flight B, they both have the same average effect on the model output. And then there's these like abnormalities, like just the fact that you're talking about flights changes the flight that the model is going to pick. And this can lead to all sorts of problems that this paper is going to warn us about, like the fact that you can do prompt engineering, but like in a much more structured way, or like basically do p-hacking, but in LLMs, do prompt hacking. So like just change the word is or remove it, and instead of saying flight, say option, and the choice probability doubles for flight B. And if you're like consumer behavior, right? If you're a consumer behavior, you might be interested, consumer behavior person, you might be interested in like understanding cognitive biases in LLMs. Turns out that for example, the framing effect. It turns out if you do say the price of flight be a little bit more positively, it does increase the probability of the model picking it up. But also, the Shapley values of this prompt still tell you that that's not the full story. Although on the surface, you got some, framing effect from the model, and the model did pay attention to only, but the token noise effect of the other tokens still exists, which means that, surprisingly, you can just change fly to option. Instead of saying costs, you can say priced at, keep the framing effect, and then the framing effect phrase, the framing effect disappears. Which begs the question, was there a framing effect in the model to begin with? So all these discoveries about language models leads us to this understanding that the better way to think about models is to think about them not as like something that has a distribution, but as something that generates distributions. I remember from Alan's course, like data generating processes like Dirichlet. And if you sample from it, you get a distribution. A language model is also like that, except that this distribution that it outputs depends on the prompt you give it. So really, like talking about, I talked about in my proposal about like some biases of these models, like risk aversion or other factors. But come to think of it, after like doing this project, talking about those aspects of models actually moot, because sure, you can measure some of the cognitive biases for a model, but then you change the prompt and those distributions change quickly. So risk aversion or like framing effect or recency effect or primacy effect, all these things that I was experimenting with before, it doesn't make sense to even talk about how a model is more or less risk averse than humans, because the very act of measurement changes the thing you're measuring. That's why it becomes a little bit philosophical, because like if you're measuring how risk averse a model is, your question is changing the output you will get. So moving on to chapter 3. Okay, I got good amount of time. I'm sprinting through it.
You're doing great.
Yeah.
Just relax.
Okay. So chapter 3 is about the trade-off that I mentioned between safety and creativity of AI models. And really, like to give a little bit of background, when firms train models, fresh out of the AI oven is this one. Like you train something, it's called train or base model, and it's useless, but it could be useful in some scenarios that I will say. Then firms usually make the model chatty, where like they make them like follow instructions. And this step, they apply reinforcement learning on the model to make it less biased, less toxic. So the way it usually works is the model generates like 2 different outputs, and then a human evaluator or a model that mimics human evaluator will pick the one that it prefers, or it scores them. So the model learns what to say, what not to say, or like the kinds of things that will give it a lot of penalty, and the kinds of things that will give it a lot of reward. That's one of the reasons that ChatGPT has so many platitudes. Before and after, it's like responses. You have to just stop saying anything else, just give me the response. It's because during its RLHF process, it was given a lot of reward for those. But that is going to cause problem. Just a little bit of a background. This is how models actually generate responses for us, right? At any point, they go on one of these branches of tokens that they can pick from. And so if the model says, I will eat breakfast, it actually is coming from a whole like huge forest of answers that it could have given. Like at any point, it could have like switched the branch and picked another token instead. And it picks those based on the probabilities. Now, let me like whet your appetite with like example. Like, a lot of us like to make simulated consumers, at least for training purposes using AI. And one thing that shocked me was like experiments like this that I replicated across various models. Like you ask the base model to give you a customer, just random customer. And it gives you like John Doe, Smith, blah, blah, blah. But a lot of that variety goes away when you switch to the aligned model. That's actually ironic, because this is supposed to be more open to like more diverse and everything. This is like potentially biased, but yet this actually leads to more variety in names. And it's not just names, we can look at nationalities. Like it's just picking all kinds of nationalities, whereas the aligned model just thinks there's 3 countries on Earth. And then there's like all kinds of other things, like the ethnicities, personality types, for my OBT friends, like, where's the rest of them? It doesn't even know them. And the age, we really like, it kind of looks like that the age distribution for the base model is going to be more like normal than the aligned model. And you can apply it, you can find it across various domains. What ends up happening is that the hypothesis is that the model loses part of its ability to create diverse outputs because of the RLHF process, and we have to look into the reasoning behind it. Let's look at a very simple example. Like the model is just going to complete this, half sentence. Grace Hopper was. Well, she created the COBOL programming language, and the model knows about it. Base model and the aligned model, both of them know about this thing. So you look at some sample outputs from these models, like the base model and the one that's supposed to be safer. And you probably notice some sort of like pattern between these responses. Just look at right-hand side. And then it's just like repeating some pattern. Like it learned to talk about historical figures in this example in just only a few different ways. In fact, if you look at the embeddings of the outputs generated from the model, and you use TSNE to put them like in 2 dimensions and under different perplexity scores, you see that the embeddings of the aligned model are very much concentrated into like almost 4 clusters, whereas the base model is able to describe this historical figure in many different ways. So this is what we call the semantic diversity. Like semantic diversity of the outputs of the base model is significantly more than the aligned model. And the hypothesis is that it is because there's a prerequisite for semantic diversity. And that is, you need to be able to generate different tokens at any step, like those branches that I showed you. You must be able to pick different tokens in order to even have the possibility of creating different meanings. And the hypothesis is that RLHF clamps and like compresses those like logits. So you can't have more options at any point. You do not have access to all of the tokens in your dictionary. Now, like if I wanted to visualize it, it's like RLHF blocking certain trajectories. So the only thing you can say, or the most likely thing you will always say is like, I will have to something. We can actually see that in action. If you give it another piece of prompt and then say, Steve is a CEO, a startup, and you look at the logits that the model assigns to the tokens as it generates them at each step. In fact, you look at the base model, at each step, the probabilities are so spread out that if you sample from it with any temperature, there's a high chance that you will end up on a whole different trajectory. Whereas for the aligned model, these probabilities are much more compressed. So like the model has already said, okay, noon with like a high probability, and the chance of actually generating different trajectories of tokens is much lower with the aligned model. In some literatures, they call it multiverse versus universe. So this aligned model generates only a universe, whereas the base model can generate all kinds of outputs for you. Now, you can actually look at the average entropy of tokens, and it is significantly higher for the base model. So something is actually happening during the RLHF process that leads the model to always pick certain outputs other than, and it loses its creativity. And it's not the end of story. It actually gets worse. These clusters that we saw, if you go ahead and like nudge the model out of distribution, so when it wants to say she was a pioneering computer scientist, you nudge it and you say she was not. You would think that nudge should be enough to push the model out of the cluster, and maybe it will find another trajectory to describe Grace Hopper in a different way. But that's not actually happening. The model gets confused. I can see by the probabilities that it assigns, because it was not expecting to see like she was not. So it justifies it and says she was not 9. She was actually 114 years old when she passed away, and then goes on to describe Grace Hopper as if nothing happened. It starts to say whatever it was going to say anyway. Again, in dynamic systems, they call this attractor states. sort of like black holes, but in the embedding space. That like you cannot escape from these. Like even if you nudge the model outside of this, you either end up in the same cluster or in the other cluster. So like the model has lost the ability to generate outputs that have embeddings like in other parts of the space. Whereas this problem doesn't exist for the base model. And a simple example that I show in the paper, what I'm going to just briefly explain here is, like, let's say you want to, this is a very simple example of how this happens. Let's say you have a model and you want to apply RLHF to it so it can generate better outputs for you. Now, like I said, you can generate two outputs and you're going to score them, right? Let's say you are creating a chatbot and the model has to name it. And it comes up with GPT and chats and giggles for some reason. Now, assume that the reward that you give to these is only a little bit like higher for GPT and like 0.8 for chats and giggles. But only through a few iterations of like applying this like policy optimization technique in RL, you end up with a probability 93% of picking GPT and only 7% of picking chats and giggles. And that's just like a few iterations. Even if you apply KL divergence, this still happens. So like there's more detail in the paper, but what I'm trying to say is that the RLHF does in fact affect the model's ability to be creative. And the message for marketers, as I think people are going to ask, how is it related to marketing? The message for marketers is you got to you seriously have to think about like the model used for various applications. So if it's a creative task like ad copywriting, or if you want to come up with like ideas for a video script, you got to go for like base models like Google's Gemma or Mistral's models. But if you want customer support agents or something that requires like consistency and predictability, sure, go ahead with like GPT or Claude or Gemini. And lastly, I'm going to briefly explain the PAL programming language, maybe in like, I have 5 minutes. Okay, cool. Yes. So PAL, why? Okay. I did tell you that we want to democratize the field of AI for small businesses. At least, like, we want to show how it can be done. A lot of big businesses have the resources to have distinct departments for various functions, like marketing, operations, finance. Marketing is at the center of everything. This is, but small businesses don't necessarily have this much resources. So Beacon, the project, basically, I named it Business Enhancement for Adaptive Coordinated Networks. It tries to create all these departments, like mini department of finance, mini department of marketing, etc., with their own subsections and stuff based on the needs of the firm. And all of these are operated by AI models that have to know how to communicate with each other, right? And they talk in PAL. That's one of the real applications of it. And so PAL is basically a language for language models. So they can talk in PAL code. And there are other approaches to orchestrating these agents. Like, it's not the only solution. There's ways like you can let them write Python code and then execute the Python code, but it's not secure. It might be prompt injection attacks, and the agents might, remove your thesis or like your presentation or something. So this is like, in terms of security, is a nightmare. On the other hand, you can have like the current solution, which a lot of firms do, is like function calling. You give this beast to the model, and this model now knows that if you ask it the weather, it has to fill in the blanks for some of the fields in this, and it has to return another JSON like this to you, and then you run it in your program. But imagine now you want to ask the model like 50 different questions. You have to give it 50 of these with each prompt that you send to the model. Quickly, it becomes problematic because the model gets confused which one of these to choose from. And also, it's confusing the model, and not to mention that it's expensive and time-consuming to always send like 100 lines of extra metadata to the model so it knows how to do things. So PAL says, don't worry about any of that. Let's just let the model talk in PAL code. And it has some features that I'm going to show. Obviously, I'm not going to get into much detail, but I just want to say that you can obviously define variables. It's a real language. You can define variables, and you can define functions. For those old enough to remember the Common Lisp era, like this is like dialect of Lisp. But with additional features, like you can then defend your thesis by calling this function, and that's it. Then you can also create lists, my awesome advisor. And then this is like, you can do dictionaries, you can do all kinds of things in it. There's partial functions, you don't have to worry about not feeding all of the arguments to a function, like +1, like normally Python would yell at you and say, well, what's the other one you want me to add? But Pell says, okay, in this case, I'm going to treat this as a function, and then next time you give me a variable, I'm going to feed that into this new function. So it's like it returns a function. And you can make all kinds of things with it. I'm not going to bore you with some of the details, but like maybe one of the most important features that I like about Pell is the pipes, which is completely different from Common Lisp and other Lisps. So like this is important for language models because they don't have the ability to plan in advance. Oftentimes what happens, let's say you're writing some piece of Python, and you write foo_x, and then you remember, oh, I should have called, let's say, another function bar before I called foo. Then you have to go, like, literally take your cursor, go back, type bar, put the parentheses, go all the way back, close the parentheses, to be able to do the function that you wanted to do. I'm talking about this. Like, so let's say you're typing bar of x, and then you remember, oh, I should have thought in advance that I'm going to feed this to another function. So you have to take your cursor all the way back, and then do whatever, foo, and then write this thing, go all the way to the end, and type it. Well, Pell takes care of all of that and says, if you write a function and then you remember, oops, I should have called it, I should have fed it to another function, you can literally feed it into another function by using these pipe arguments. So the way it works is it takes like this list that you created, it feeds it as by default as the first argument to the next expression. So it's now under the hood, this whole thing is like length of 1, 2, 3, 4. So the value is 4. Then it takes that value and injects it as the first argument to the next one. And now it's like 4 plus 11 is 15. And you can also inject it to any other argument. Like now it injects the value of the previous expression as this argument. So it's now dividing 13 by 15, and the answer is 2. You also have natural language conditions. Like if you want to do sentiment analysis, usually you have to get some NLP libraries, but in Pell you can simply say companies' finances are doing great. This is, let's say, an agent's report, and then you put it in. You literally can ask the programming language, are things all right or whatever. You can just literally ask the condition in natural language, and behind the scenes, a language model is going to evaluate this according to the criteria you asked, and it's going to say yes, so you print stunks, or big sad or whatever. So simple or sample agent code is like this. You ask the model to, based on the finance data of the company, come up with a better marketing strategy. We know that the model has to first query the finance agent, get a report from the finance agent, and then push that report to the marketing agent. So it's like you get that report, you expect a number, let's say the budget allocation for social media marketing, and it basically sends that as extra context to the marketing agent. Let me just, before I leave you with everything, here, like, sure you can see, this is an example of Beacon and with Pell. So I have these agents, don't worry about it, but it's like we have a finance, and a subdivision of finance is financial planning. And we can ask, how many employees do we have? And well, typically it has to ask the, okay, it gave us the answer. What it did behind the scenes, it wrote Pell code to query the HR department, and then put it here, and then like sort of polished it for us. The HR department responded to the request, and like you can ask it all kinds of questions. Let's see, what's the current marketing strategy? So like, again, the marketing agent is invoked. The marketing agent itself might write some Pell code, so it's all recursive. Behind the scenes, this is what's happening. And you can see that when all of the marketing agents subdivisions provided a response, it accumulated all of them and then created this whole like marketing strategy that we've had in the company. Now, a small business will feed this additional data to the Beacon project, and so the agents will take the work and go ahead and do things with it. So that's the idea. The PAL programming language is a language for language models that allows them to orchestrate each other and coordinate and communicate with each other. And by doing this, it's much more efficient. You don't have to send those like JSON files every single time, and it's much more secure as well. I think my time is up, but thank you so much. I just like, I know that presentation is over, but I also want to thank a lot of people that have been with me on this journey, and obviously my advisors, Tim and Alan, and my co-author, Nikhil, and Kannan, who also has been a co-author, and really like my committee for showing interest in my research, and my friends, and obviously above all, like my partner, Elizabeth. And I appreciate you all. Thank you.
Questions?
Yeah, any questions?
Maybe it'd be helpful if we organize questions around the chapters.
Okay.
Any proposal to go back to the first one, or should we start with the fourth chapter?
Let's go work backwards.
Or is it fifth chapter?
Fourth
chapter. So I'll start with the fourth chapter.
And you can also maybe do the...
Yeah, with the fourth chapter. Impressive that you created in such a short amount of time. And there's some application to it as well. Could you simply, I'm thinking about this from a marketing of this tool that you've created, would you think of this as an industry-wide, or sorry, not a firm-wide chatbot, like a firm-specific chatbot to then facilitate engagements across departments or silos, such that I don't have to call Alan anymore in marketing if I'm in finance to see what his budget is, or vice versa, and I can just look it up from an industry-wide set of information, or sorry, from a company-wide information, and get a response.
It is possible,
quickly,
in
as
fact.
opposed to waiting for an email response from someone, etc. So
it is definitely possible. Like the thing that it does is it takes some data from it takes some data for sure. Like let's say Alan's agent puts his emails or whatever in a piece of JSON file. So it is definitely possible for your agent to autonomously say, okay, we need to first make sure our calendars don't have any conflicts. So really it's all about providing the context, and this context can come from an agent itself, and it updates it. And yeah, so and this is all of it. Like this whole like JSON that you see, maybe I should do this. This whole JSON is like the company data in this example. So
Nikhil has a question.
So for the Pell language, is there an evaluation metric or test to quantify if the developed language is working well?
Oh, that's a good question, Nikhil. So like there is some ongoing work in the literature about how just the fact that you ask a language model to respond in JSON reduces the performance of the language model, which is actually ironic because like it's supposed to be trained for function calling. So like we're basically trying to say no need for any JSON output. Like the language model should be able to generate just the code or like text or whatever that was going to write without being enforced to necessarily output JSON file. There are like when this Beacon project fully finishes at Tepper, the idea is to see how this can like improve the accuracy of the agents that are being called. Because like right now in the Beacon project, I showed like a few sort of departments, right? When you have, let's say, 50 agents, at a very highly deeply nested sort of hierarchy, it becomes challenging for language models to output JSON. So yeah.
Are you planning to do any of the evaluation tests as part of this paper?
Yes, it's going to be comparing it with the JSON approach. Yeah. But the comparison with the Python approach is already done, because the Python approach means that you ask the model to write some Python code and then you just execute it. It might be dangerous. So what Pell does is it goes ahead and says, at the generation level, I'm going to make the model not even be able to write malicious code. So that part doesn't need evaluation because it's like done theoretically. So basically, we create regex masks for the output that we want, and we make sure that model cannot even generate malicious code. So that part is done. But yes, we will compare it with the other JSON approach as well.
I had a question about Pell.
Mhm.
I'm not clear on the error correcting nature.
Ah.
I would understand this as semantic problems that
Mhm.
arise, not some syntactical ones. Or am I misunderstanding that it can detect both syntactical as well as semantic errors?
That's a really good question. It has an interactive environment that usually in programming languages, they call it REPL, R-E-P-L, but I just had to call it REPL. And this is actually a good question. Let's say I have a data like this. I defined a list or a map. But maybe I want to print it and I want to, I wrote hello audience before. But let's make some syntactic error. When this happens, the program doesn't crash like in Python. And this is important for agentic AI because you don't want the one part of, like, let's say you have 100 lines of Python code and line 74 fails. Usually the whole program fails. You have to start over. Pell says we have error correction. It's actually one of the cool features of it. You have self-healing feature, which means an AI agent that's baked in the interpreter auto-fixes your code, which is kind of like cool, if you ask. So you can say, OK, it realized that you made a mistake when you wanted to call the print function. This is a syntactic error. And it fixed it for you, and you can accept this change. And OK, now the code works. So it's like this. It's like autocorrect, but for your code. You also, as the programmer, have the ability to fix it yourself. Like if your program crashes, it's not the end of the world. You can just say, well, OK, I'm going to remove this part, continue evaluating this thing, and it still works. Yeah. But the agents, yeah, they also fix the semantic mistakes. Yeah.
A broader question for you about Pell is one of the reasons that people like LLMs is they get to communicate in English.
Yeah.
So you give the example where there's a large meta-programming task. So I would understand that would be a natural occurrence where we want to use something like Pell.
Yeah.
But otherwise, I'm not sure I would see that Pell would be helpful for regular applications. So this is more specialized for large simulations. Am I right? Or are there other applications that you have in mind where you think Pell is dominant?
Well, if you think about structured output that you want to get from models, as soon as that happens, you can use Pell. So Pell is like a lighter alternative to that sort of JSON approach. So like in a lot of cases, even if you don't have agentic AI, you still want to use some, you still want to give the model some ability to call functions or do actions. This can be done the usual way, which is like we send this additional metadata every single time. Or you can just train the model or in context teach it to write Pell code, and then you just execute Pell. Yeah, it's good for orchestrating, but also good for just regular tasks. And also, even though it's made for language models, it's also useful for humans. They can also write in Pell. I know from my own unbiased opinion, it's a joy to write in Pell. Not because I made it.
I
don't
think I've heard a lot of people say, I wish we could program more in Lisp.
Because they didn't have these pipes. Yeah, I can say this.
That's the only thing lacking.
That's it. Yeah. Yes?
So is it possible to relegate Pell sort of to the back end of this hierarchy and organization of AI agents and keep sort of the terminal in English for the user?
You mean as the user who interacts with Pill, you talk in English, and then it responds in English. That's what the beacon thing does. Like when you run it, you ask questions, and in practice, I don't show all the detail here, but I can just say, hell, how many departments do we have? And you talk in English, and it like responds in English. But behind the scene, it might write Pell code or do anything, and that's like in the backend.
Going back to the other two chapters, more questions?
Yes.
Can I ask a question on chapter 4 before you finish?
Okay, there's two questions. You want to go? Zoey and Nikhil have questions. What's that?
Oh, sorry. Yeah, in the
Zoey?
alignment process, you have like these two steps, which is one turning the base model into this more conversational one, and the other is like this reinforcement learning part to make sure they behave in certain ways. So
that's right.
I intuitively thinking it sounds like this less diversity happen most like in the second stage where the reinforcement.
Where the reinforcement.
Stage. Yeah. So like, is your project or paper going to also talk about that, like theoretically, what stage this is happening, or does it matter like this alignment?
Well, for companies, it matters. They want an aligned model. Like ChatGPT is aligned. You can't make it do, like it's very hard to make it do biased outputs. And since there's only two stages, we know that something happened during that RLHF process. Your question is like, what's the theoretical implication of the RLHF?
Because you are like on the slides, you're comparing the base versus aligned.
Yeah.
And then like this chat in between. That's why I'm like asking. The chat doesn't matter too much for you, right? Like making a model.
Well, yeah. Oh, you mean the chat part? Yeah. If you want to get chat outputs, you can even get it from the base model. Yeah, that's why we don't really care that much about this. It's like the typical fine-tuning that happens here. There's no reward function here. So like we're just basically fine-tuning the model to know that if it sees a question, it has to answer it instead of continuing the question. Yeah, but because we are using open source models, that's one of the things that it unlocks. We are able to look before and after. Like this kind of research, you can't study this for ChatGPT because you don't have access to the base model. But because like my models are Llama 2 and 3, like I can see before and after. But what Llama 2 or 3 does is it combines these two in one file. So we can't really get deeper and see what happens in between, But yeah, we know that the problem is the like optimization strategy because it's wrong to treat a language model as if it's a policy that you're trying to maximize or optimize. But that's what's happening with RLHF, and it reduces the creativity.
I'm just curious. So is the alignment process making the creativity goes down, or it's currently how this is like the objective function is? So for instance, in your this example is giving two rewards, one is higher, one is lower. Intuitively speaking, we should be expecting that like lower weight will be outputted for this lower reward option. But if you were to structure this reinforcement learning model to motivate and encourage diversity, do you think theoretically that's like the alignment issue, or is currently how we?
I think it's less about the content of RLHF and more about the way it is done. Like here, RLHF was supposed to make the model like even better in terms of diversity, or like less bias, be more like inclusive. Turns out it actually backfired, like in this specific model. The model lost ability to even talk about different ethnicities, countries, names, etc. So it has to do with the way the way the RLHF process is implemented in practice. I went back and I tried like the paper that came with the Llama 2 model explains it in detail how they did the RLHF. Ideally, you want the model to look at the difference between the rewards that you give to each output, and then just instead of like completely forgetting about one output, you want it to just pick one more likely than the other one. With more probability, you would say the correct way of like implementing RLHF would have been pick GPT with more probability because it has a little bit more, reward, and pick chats and giggles with a little bit low probability. But because the way the implementation of RLHF, it ends up picking chats and giggles with 0 probability just after a few iterations. So it's like it could be like a future research to see if it's possible to sort of, instead of like telling the model that I'm giving you this feedback and never say this thing again, make it just say it but with lower probability.
Yes, yeah, it's going to be interesting.
It would be interesting,
like
yeah.
how to, like kind of revise and improve that.
That's right, yeah. There are some methods that have been proposed, but we'll see. Thank you. That's a good question. And also, I remember Nikhil had a question.
Yeah, just a quick question. I think just unfortunately going back to chapter 4.
Okay.
Do you use the LLM to also help with ideating on how to develop the Pell language?
Did I what?
Do you use LLM to ideate on how to create the Pell language?
Unfortunately, they don't have like the syntax of. Actually, this was one of the toughest use cases of LLMs in my experience, because this syntax with Pell, I tried to use it, but this syntax where you have pipes and also Lisp code, I have never seen it anywhere else. You have pipes inside Lisp code in some languages like Clojure, but you don't have this. So like when I was like trying to see if like I can ask, let's say O1 to like help me with like developing the language, it would always kind of like, it's like regression to the mean. It would always like go back to like other languages that it had seen in its training data. So it wasn't really useful in ideation stage. Yeah.
One last question for me. Going back to the Shapley value paper.
Mm-hmm.
Usually in economics, you assume rationality, whereas in marketing, you don't. You tolerate the idea that people may deviate some.
Yeah.
So I can't tell whether these phenomena about priming and framing, they seem desirable in many cases, but in your argument, it's undesirable because they have too much influence over what's going on. So it almost seems like you have a firm belief about how price should enter in, and that there is some additive utility model that should underlie the way that people are actually behaving, and the fact that people are deviating too far from what you believe about is a reasonable utility model is the artifacts that you've discovered. So I'm just curious, what how do you feel about this statement that these things are desirable as opposed to trying to say that they're undesirable? I know part of your goal was just to try to demonstrate they exist, but here I'm just trying to probe further and understand, are they really that bad?
When you say these effects, which effects? I guess
so like in this case, I like that $600 has an impact. I think that 6 versus 700 should have a much larger impact. I know that some of the words like from and to, okay, maybe less important, but it's clear that you can change the syntax and dramatically change what the outcome is going to be.
Yeah.
So all I'm saying is that a priori, I figured that prices should dominate in this context once it understands that it's in a flight context. So I mean, part of the problem here is that the LLM is just trying to understand that this is a purchase context about flying.
Yeah.
So now all of a sudden, where you go from and to is important, whereas if I'm buying my favorite brand of yogurt and I add from and to, I know it shouldn't matter at all.
So you're saying these should also matter, these other tokens? Yes.
I would take more time to formulate my question because your graph doesn't quite match up with the intuition that I was trying to articulate. But there are clear, like flight has a big role times, whereas once it understands that the flight context shouldn't really matter that much.
Yeah, like the first time it knows that the question is going to be about flights, and yet the mentioning of flights again in the flight data changes the, like, let's say flight A or B probability. I agree, like some of these should, like obviously all of these are supposed to matter, like in order for the language model to know the context. Like if I were asking it, like, I want to get some yogurt and these are the flights available, which one would you pick? It would probably not, give it enough context to know what I'm talking about. The problem here is that, and going back to the modeling that you mentioned about humans, I would suspect that because we know that humans can make irrational decisions as well, I would suspect that some of this effect we would have detected in humans too if we could run Shapley values on them. Like if we could erase their memory after each question and then ask them again, I would suspect that we could, but just because we can't run it for humans doesn't mean that it doesn't necessarily exist. And maybe the real sort of underlying question is, okay, maybe the LLM is actually mimicking humans correctly. It's just maybe this much of it is correct because humans would also have had this much influence by the cost, but maybe it deviates a little bit from human behavior. But going back to the modeling that we have in marketing, we do not include them in the utility function, even for humans. Like when we do, let's say, conjoint analysis, we just say, well, okay, price and travel time, etc. And we want to find the coefficients of those, but like we know that some framing effect exists, and we might need to repeat a question a few times to kind of average it out. But I don't see anywhere in the literature that says just like white space or the number of new lines after the question or like auxiliary verbs or whatever other words you have like a coefficient in the utility function. Like because that epsilon that we have usually in the random utility models is like the same scenario, the same like set of products. You pick something else, and we attribute it to some random utility. But this is different than that because it's almost the same scenario, except that the prompt has slightly changed a little bit. So like the fact that you pick another product, it's not just that epsilon, it's also because, there was some effect of the wording of the question. But we don't model that usually in marketing, and I guess we should, but when we don't, and then we expect that, okay, we're going to be able to just use LLMs as proxies for the same human studies that we had, that's where things become problematic, because at least we can see that LLMs are under influence of a lot of other factors that can change their decision. Yep.
All right, if no other questions, I think that's time for all of you to step outside and allow us to discuss. All the faculty,
Okay.
Okay. And guests.
Should I make Alan host? How do I?
Yeah, just
Alan, are you?
the screen.
Let me close it.
Of just
Let's make Alan.
So
Anna, show me
microphones. Transfer the co-host to me.
Okay. Host. Thank you. Thanks, everyone. Thank you. I'll see you outside. I mean, just have to make Alan.
And stop the recording.